Welcome to today's deep dive. Imagine spending, the equivalent of a luxury car over $55,000 on a single invisible metal box.
Right, a box that literally just directs video signals.
Exactly. So today, our mission is to unpack the high-end enterprise technology powering those massive video walls you see every day. We're looking specifically at the specs for the Smart-AVI MXWallPRO-6464-S from HDTVSupply.
It's quite the mouthful, yeah.
It really is. Okay, let's unpack this. Because with an MSRP of almost $80,000, though it's currently sitting at, I think, just under $56,000, that implies this thing isn't just playing video.
Oh, definitely not.
What kind of data load demands that kind of investment?
Well, you're paying for the invisible backbone of highly demanding 2,147 environments. This is, it's a purely hardware-based matrix routing and video wall solution.
So we are talking mission-critical stuff here.
Exactly. It's built for places where a crashed screen just isn't an option. Think of those massive departure boards at international airports, or maybe multi-story digital canvases in shopping malls.
Or even complex multi-screen grids inside security operations centers,
Right, exactly. The stakes are really high in those spaces.
So to manage that much data without crashing, it acts like, well, the ultimate digital traffic cop.
That is a great way to put it.
But not a normal traffic cop who only lets one lane go at a time. Think of this as like a fourth-dimensional traffic cop. It can instantly route any of its 64 incoming high-speed video lanes into any of the 64 outgoing lanes simultaneously.
And doing that without slowing a single bit of data down. Keeping those 64 lanes flowing freely requires some serious engineering.
I can only imagine. How does it actually pull that off?
Well, it achieves its 64 by 64 capacity using 16 input cards and 6 output cards. And each of those features 4 HDMI 1.4 connectors.
Wow, that is a lot of connectivity packed into one box.
It really is. But what's fascinating here is how it treats the video itself on the fly. It automatically scales the incoming signals to 1080p at 60 Hz.
Wait, so it doesn't rely on software for that scaling?
No, not at all. Instead of relying on software processing, which, inevitably introduces a buffer, this device uses dedicated physical pathways on the motherboard.
Ah, so because it is entirely hardware-based, processing happens in real time.
Right, which guarantees zero latency. It bypasses the operating system completely.
So there's no lag, no freezing up while a CPU tries to catch its breath, which makes total sense as an absolute requirement for an always-on security or flight display.
Exactly. You can't have the airport board freeze because Windows decided to update.
Oh man, definitely not. But here's where it gets really interesting. We are talking about a highly complex 30-pound hardware beast, right?
Mm-hmm.
And it chugs 300 watts of continuous power.
Yeah, it is a massive piece of hardware.
So how does a human actually interface with it to change what's on those 64 screens? You would expect a massive, complicated control deck straight out of a sci-fi movie.
We really would, but actually the interfacing is pretty standard and surprisingly straightforward.
Really? How so?
Well, along with the Windows setup software, you can manage post-setup adjustments and layout changes using a free Android app.
Wait. I have to push back on that. A free app?
Yeah, just a regular free app.
Doesn't that seem incredibly insecure? It feels completely wild to think that highly secure, enterprise-grade airport displays could be tweaked using a casual free app on someone's phone.
I know, it sounds super casual at first glance.
It seems like a massive vulnerability for a city's security grid.
Sure, but you have to separate the command from the execution. The app isn't processing video or accessing the core network data.
Okay, so what is it actually doing then?
It's merely sending a basic layout instruction. Like, it's telling the system to stretch input A across 4 screens, or maybe keep input B 1-to-1.
Oh, I see. So the software is just a remote control.
Exactly. Heavy lifting, the scaling, the real-time routing, the actual rendering, all of that is entirely locked down. It's handled by the plug-and-play hardware inside the box.
Got it. So the app simply switches the tracks, but the hardware is the train.
That is a perfect analogy, yeah.
So what does this all mean for you listening at home? Next time you are standing in an airport staring up at a perfectly synced wall-to-wall departure board, you will know exactly what is sweating behind the drywall.
Yeah, a heavy-duty, hardware-level matrix switcher furiously routing dozens of uncompressed video feeds to make that image seamless.
It's pretty incredible when you think about it.
It really is. If we connect this to the bigger picture, we are seeing a fascinating blend of uncompromising, dedicated hardware paired with incredibly accessible consumer-level software.
It really bridges that gap, doesn't it?
Right. It simplifies the management of massive enterprise technology without sacrificing the raw processing power required to run it securely.
Which leaves us with something really interesting to ponder. With enterprise AV tech allowing for such easy, real-time manipulation of massive public displays, literally from a phone in someone's pocket, how might this shape the future of ambient advertising?
That is a really great question.
And think about the visual information we are flooded with in our daily lives. If the digital traffic cop never sleeps, the roads of our visual world are only going to get busier.